Alright, so these are notes for section 4.2, right triangle trigonometry. And in order to start talking about trig, we need to understand that what an angle looks like in standard position. So, if I had a coordinate plane, and just bear with me on this coordinate plane, an angle in standard position is always going to be with one of its rays sitting along the positive x-axis and the other ray pointing off into the first quadrant. So an angle in standard position always looks like this. In trigonometry, we always go back to this same, and you might have heard this before, SOHCAHTOA. Yep, bringing it back. So we have, if I call this a triangle ABC, and I call this my theta, I can easily see that this is the hypotenuse. This only works with right triangles, remember, so I'm going to tell you that that's the right angle. That's the hypotenuse. From theta, this side is my opposite side, and from theta, this is my adjacent side. We have 6 functions that go along with these 3 values. The first one is sine, and sine is always opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse. And we have tangent, which is opposite over adjacent. This is where we get the SOHCAHTOA from. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. If that helps you remember, fine. If you need to think of some other way, feel free to do that. These functions also have inverses. So cosecant is going to be the opposite, hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. You need to know these. Must know all of these. You'll be able to figure them out most of the time if you know a couple of them, but you must know how to find every single one of these. We have 2 types of right triangles, 2 special types of right triangles that we generally talk about. The first is a 45-45-90 triangle. So 45 degrees, it's pretty simple. You know that this is 90 degrees, so this angle must be 45, and this angle must also be 45. If I say that this is 1 and this is 1, they're the same length, so if it's in a circle, radius 1, you could find this side by using Pythagorean theorem. A squared plus b squared equals c squared. So 1 plus 1 is 2, and take the square root, you know that this side is going to be root 2. I need you to find those 6 trig functions using just this circle. And you know that it doesn't really matter which angle you use because they're both 45 degrees. Once you choose an angle, always use that one. I'm going to use this one. So I could say the sine of 45 degrees is equal to opposite, which is 1, over hypotenuse, which is root 2. Now normally this would be fine, but since we have a square root on the bottom, you're not allowed to have an irrational denominator. So how do we get rid of the square root? We have to multiply by 1. Root 2 over root 2 is actually the same as 1. So it's going to give me 2 on the bottom and root 2 on the top. Root 2 over 2 is the same as sine of 45. Now you need to find the cosine of 45. Cosine is adjacent over hypotenuse, so adjacent this time is 1. Hypotenuse is root 2. Again, same thing. You're going to have to multiply by 1. You're going to end up getting root 2 over 2. Find the tangent. tangent is opposite over adjacent. So this one's pretty easy. It's just 1 over 1 or 1. Now I want you to find cosecant, secant, and cotangent, all of 45 degrees. Hopefully you got these for answers. Let's move on to the second type of triangle. So the other type of right triangle that we talk about a lot is a 30, 60, 90. 30, 60, 90. In a 30, 60, 90 triangle, this is your right angle, so that's your 90 degrees. 30 degrees is up there, and I'm going to put 60 degrees down there. Now, it really doesn't matter. I could draw a triangle either way. But what you need to know is that if this is 1, then this must be 2. Oops. And this must be root 3. So we're going to do the same thing. Find the sine of 30. Sine of 30. So now I have to go to this. Now it matters which angle you're looking at. I'm looking at the 30-degree angle here. Opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. So 1 over 2. Then you're going to find cosine of 30. And you're going to go all the way through these. Tangent, cosecant, secant, and cotangent. Then, after that, oops, I forgot to write a 30 in there, we have another angle. So now you're going to have to find the sine of 60 degrees, and this time you're going to use this angle to find it. So if I'm using 60, my opposite is going to be root 3, and my hypotenuse is still 2. So the sine of 60 is root 3 over 2. Same triangle, but sine of 60 is different than the sine of 30. They have opposite opposites, if that makes sense. So what I'd like you to do right now is find all 6 functions for both 30 degrees and 60 degrees. Now you could check your answers here to make sure that you have the right one. If you're looking at your answer and you're saying, oh, it's pretty close, but it looks a little bit different, it's because I've rationalized all the denominators. So for example, tangent of 30, you probably got 1 divided by root 3. You have to rationalize it by multiplying by root 3 over root 3, and you should get root 3 over 3 for a final answer. So all of my denominators are rationalized here. You may have to do the same thing. In this next example, we're going to use one trig function to find all of them. So the only information that I will give you is that the sine of theta is equal to 5/6. So what does that mean? Well, first, I need to draw my triangle. And I know that if I call this one theta, sine is opposite over hypotenuse. Right away, I know my hypotenuse is 6, so if this is my right angle, I know this has to be 6. My opposite has to be 5. And now I can use Pythagorean theorem to find the length of this last side. So I would do 5 squared plus x squared, because I don't know what it is equal to 6 squared. 25 plus x squared equals 36. So that means that x squared is equal to 11. So that means that this has to be the square root of 11, since I know it can't be a negative number. Now you have your triangle. So now you should be able to find cosine, tangent, cosecant, secant, and cotangent. Try it. This is what you should get for answers. Remember, I've rationalized all of my denominators, so you need to make sure that you do the same. Okay, so we call this solving a right triangle. So you might find a question that says, a right triangle with hypotenuse of 8 inches and a 37-degree angle. That's what they give you. Find the measure of the other 2 angles and the lengths of the other sides. So the first thing that we're going to do is draw our picture. It tells us that one angle is 37 degrees and that the hypotenuse is 8. Well, right away, since it's a right triangle, I can find my other angle. 90 plus 37 plus what number equals 180? That would be 53. So you've already answered part of your question. Now, you know that the sine of 37 is equal to opposite over hypotenuse. If I call this side A and this side B, I would say that the sine of 37 is equal to A divided by 8, opposite divided by hypotenuse. I can easily solve for A by multiplying both sides by 8. So now I can say that A is equal to 8 times the sine of 37. You should get approximately 4.8. Now you can do the same thing with cosine. We know that the cosine of 37 is actually equal to adjacent, or B, over hypotenuse. So once you solve all that out, you should get B is approximately equal to 6.4. And that's it. You're done. You solved your triangle. You know all 3 angles and you know all 3 sides. So you have solved a triangle. Sometimes you might get a question, and this is what they call a real-world question. Let's pretend this is some type of building. It has windows and whatnot, and it's really, really tall building, so you really don't have a ladder that can get to the top to measure the building. But you do know that if you stand on the ground here, 340 feet away from this building, so 340 feet away from the building, you know that this is 60 degrees. Now you can find the height of the building. It's easy, right? You know the adjacent side and you're trying to find the opposite side. I'm sorry, this degree measure is 65 degrees. So what I'm going to do is take the tangent, because tangent is opposite over adjacent. The tangent of 65 degrees is equal to opposite, which I don't know, is h, over adjacent, which is 340, and I'm going to solve for h, just like I did in the previous problem. H is equal to 340 times the tangent of 65. And once I multiply all that out, I get h is approximately equal to 729 feet. Pretty easy once you know everything about sine, cosine, tangent, and all the other trig functions. That's it for this section. In the next section, we're going to be talking a little bit more about trig functions and how we can use them to find different angle measures.